Okay, a little more practice now with chemical equations. We're going to do a few things. We're going to classify some equations. We're going to complete some equations. So I'm going to give you a part of the equation, and you're going to have to fill in the blanks based on the information. And we're going to name a bunch of the compounds as well. So we're going to do a little bit of everything just in 3 examples. So let's get started. All right, we're asked here to complete the chemical equation below. Then we're going to classify the reaction, we're going to name the compounds, and then we're going to balance the equations. Okay, so we got a few things to do here. First of all, we want to classify the equation. We need to classify. So that means, is this synthesis? Is it a decomposition? Is it a single replacement? Or a double replacement. So that's what we're looking for here. Maybe it's combustion. Those were our types of chemical reactions. So we're going to classify our reaction here. Now the big clue is they've only given us one line here. So there's only one product. Well, in any of these, if we have one product, the key is that is one of the keys, for synthesis. If there's one product, that is the key characteristic of a synthesis reaction. We're going to take 2 small pieces and form one larger product. So this can only be a synthesis reaction. So for part A, if we're going to classify this, this is going to be synthesis. Okay, so how about B? We need to name the compounds. Well, we're going to have to figure out what this one is. So we're going to have to use our techniques for writing formulas. Now, if I go to my periodic table and I look these things up, and I have potassium and I have chlorine, I have a metal, and then chlorine is a nonmetal, so this is an ionic bond. So I have an ionic bond, I'm going to need the crossover method. So I'm going to set up my crossover method here. So I'm going to use my K and my Cl, and I'm going to put in the combining capacity. So I need my periodic table handy. My combining capacity for potassium is +1, and chlorine is -1. So now, when I cross over, the 1 is going to move down here. The -1 here, just the one part of it, is going to move over here, and I'm going to get KCl, K1, Cl1. I don't have to write the 1, so it's just KCl. And there is my product, KCl. So let's name these compounds. So what do we have? Well, we have 3 things. First of all, we have potassium. Then, with the Cl2, we have chlorine gas. That is one of our special diatomic molecules that we talked about. And finally, what did we just build? This KCl is potassium. We named the metal. We named the nonmetal chlorine, but we changed the ending to ide, chloride. So that is potassium chloride. Now we have one more part of this, so I'm going to just slide this whole thing up. And I'm going to rewrite, just so we didn't forget. We had K plus Cl2, it comes as chlorine gas, and then we had KCl, our potassium chloride. And we were asked to balance this equation. So I'm going to balance this equation, and that's about counting. I have 1 K, I have 1 K. I have 2 Cl's, I only have 1 Cl here. So I need more Cl, so I'm going to have to add another potassium chloride. Now I have 2 Cl's. But that messed up my potassium a little bit. I have 2 potassiums. I only had 1 over here in the reactants before, so I need more potassium here. So when we're all done, what do we have as a balanced chemical equation? I need 2 of my potassiums. I need 1 of the chlorine gas, and I don't have to write the 1. And I need 2 of the potassium chlorides. And we've answered all of the questions for that particular example. Let's try another one. Once again, we want to complete the equation. We're going to classify the reaction, and we're going to name the compound. So we don't have to balance this time, but we have a few other things that we have to do. All right, so this classifying the compound is going to help us to complete. So I'm going to actually classify it first, and let's look at what we have. In terms of hints here, they've given us 1, 2 products, but if we look closer at the reactants, we have a single metal here, lithium, and then we have this compound. Well, once again, if we go back and re-watch that lesson on classifying reaction types, when you have this sort of setup, the only thing that can happen is the lithium is going to come in here and it's going to knock out that like element. So it's a metal, it's going to knock out that metal. So magnesium is going to end up all by itself. So let's put that one in. There's the magnesium all by itself. Now what are we going to have left over here though is that bond between lithium and bromine. Now we can't just write it out. It's not just going to be LiBr2. We have to go through the proper method for finding the formula. So lithium is a metal, bromine is a nonmetal. I'm going to once again use my crossover method. I go to my periodic table, lithium is +1, bromine is -1, and when we cross over, I'm going to take the 1 and the 1 over here, cross that one over, and I have LiBr, LiBr. So when this switch, notice when lithium moves over, we only need one of the bromines to bond with the lithium to complete that compound. We're not asked to balance this one, so that doesn't matter. But we do now have the completed chemical reaction. Let's also look at what type of reaction was this? Well, this was a single replacement. This was a single replacement where one element all by itself moved in and kicked out the other one. That was a single replacement. One thing, single, replaced the other like element. And then finally B, what do we have here? Well, if we look at the reactant side, we're just going left to right. I have lithium. Then I have MgBr2. Well, that is an ionic bond, metal and a nonmetal. So we name the metal magnesium. And for the nonmetal, bromine, we change the ending to "ide." So that is magnesium bromide. What do we have in our products? Well, now we've kicked it out and we just have the magnesium all by itself. And we have lithium bromide. Same idea. Name the metal, lithium, name the nonmetal, change its ending. That is lithium bromide. One more. Classify the chemical reaction below and name all the compounds. Okay, so let's classify this. Big hint here, we have a rather large chemical equation. We have a compound, we have another compound, compound. So we have a whole bunch of compounds. Chances are this is going to be a double replacement reaction. That I'll just use that DR as a double replacement. Let's just make sure that this is in fact what we're going to do. In a double replacement, we think of these first elements switching places. So the H is going to move in with the OH, the PB is going to move over with the SO4. And that is in fact what we have. We got the PB with the SO4. We have the H in the OH. Well, that's water. That's H2O. So in fact, this is a double replacement reaction. So in terms of classifying, this is double replacement. Now, did anyone get something a little bit different? In one of our previous lessons, in one of the previous lessons, we actually had a special type of double replacement reaction. I'm just going to, erase some of this so I can really rewrite on top of it. But if we look at this reaction again, we can see we have H with something else, and we have OH on the end of this one. Well, that was an acid, something that starts with an H. A lot of times it is an acid, and if it ends in OH, that is a base. Another key here is one of our products is water. This is actually, it's still double replacement, and if that's all you said, that is fine. You have the class of reaction, but this is actually a neutralization reaction as well. So neutralization. And we have an acid and a base. There's water. That means this must be a salt. And we identified some of those in a previous lesson and worksheet. Okay, let's go to maybe the harder part of this one, and that is naming all of these compounds. Naming all of these compounds. Well, the big hint here too is because we have these things in brackets, these are polyatomic ions. The key ion, these are all ionic bonds here that we can name, at least for these first three. This one should be pretty good. We've already named that one, water. Okay, so let's start naming them. We'll name them kind of left to right again. So H2, this is ionic, so I'm going to name the first part hydrogen. And then SO4, well, I'm going to have to go to my periodic table, common polyatomic ion chart, and I need to find SO4. And if I grab mine and look at SO4, that is sulfate. So that first compound, the acid, hydrogen sulfate. Okay, now this one is kind of hidden here, a tough one, but I look at Pb, that is lead. I have OH, that's my polyatomic ion, that is hydroxide. So I find that. So it looks like lead hydroxide, but some of you may notice I left a little space here because when I go back to my periodic table and I see lead, there's a couple of different things that lead could be. Lead, just tracking it down. Lead could be +2 or +4. So let's do a little reverse crossover here. So Pb OH4. Now, if I reverse crossover this 4 actually came from up here on lead. There's a 1 understood here that came from hydroxide. So it looks like lead 4, and I can verify that when I go to my polyatomic chart. Hydroxide is supposed to be -1, so this is lead 4 hydroxide. That's a tough one, but we have to be specific. This is lead 4 hydroxide. Now the nice thing here is once I've named lead 4, when it moves over to the other side, it's still lead 4. So this next one is still now lead 4 sulfate. And what do we have at the end? We can just say water. That is water. All right, that's a tough one, and that would be really tough. You wouldn't have to do all of that, but definitely different parts of that. I could just give you H2SO4 and say name that compound. Or we can identify this as a double replacement reaction. If I wanted to be specific, I could say this is a neutralization reaction and ask you to identify all the different parts, the acid, the base, and the salt. Okay, now I don't mean you to do that right now, but with practice, you should be able to do that. Okay, so we'll keep practicing. We'll do a couple more quick ones tomorrow.